All righty, guys, look at all of you here. It's nice to see everybody. This is MAC 1140 pre-calculus. It's our first meeting. The section number is 008. Today we're going to go through all of the sort of first day stuff, the normal things that you do on the first day of class, but we are going to also talk a little bit about mathematics. So I invite you to make sure you take notes, pay attention. The syllabus stuff we're going to talk about today is definitely pretty important, things you want to remember, but we'll walk through that all step by step. I guess the first things first, my name is John Filesticker. I'm an assistant professor here at Santa Fe. I got my MS in math at UF about 5-6 years ago. And since then I've taught at a few different universities in the state, UCF, USF, and UF before getting the professorship here at Santa Fe. Let me show you sort of the basics of how class is going to look. So I am going to share my screen. I'll ask that you kind of leave that maximized so you can see what's going on over here, because the notes will be coming to you in this form. There we go. All right. So kind of think of this document cam right here as the blackboard in class. Anything that I put on this doc cam should go into your notes. Like I said, this is MAC1140, and then the section number is 008. That's pre-calc. And the date today is 8/24/21. Today, we will do all the normal first day stuff. So that includes going over the syllabus, an introduction to Canvas and WebAssign, talking a little bit about class policies, and then we are going to start talking about chapter 1, which is just a bunch of preliminary stuff. So like different number systems, the real numbers, kind of how to think about and understand the real number line, because it's something that's really not given a whole lot of love in previous algebra classes, and I want to make sure we're all on the same page before we dive into the challenging stuff. Now, if you give me just one moment, my wife just came in. We had a dead battery in our car, so I'm going to update her a little bit about what's going on. I'll be right back. Alrighty, guys, thank you for your patience. So again, today we're going to go over the first day stuff. That means we're going to talk through the syllabus. I'll show you the Canvas course and how to use WebAssign a little bit. We're going to talk about some class policies and sort of specific things that I do different than maybe some of your other professors have done. And then we're going to start on chapter 1, which is the preliminary content for this class, talking about real numbers and, you know, topology, interval notation, some other notation for sets, things like that. And so let's do it in order, shall we? Let's go to the first day stuff. I will show you where to find the syllabus. That has a bunch of things that you're going to need. I'm going to ask you to do a few things along with me rather than just listen. So let's do it. Over here, I have Canvas. I'll just go fresh to our course here, right? So you guys are section 008. The homepage looks like this. My name is here, John Filesticker. Class meetings Tuesday, Thursday from 11 to 12:15. Obviously, you figured that out because you're here. Office hours, right now I have them set to Monday, Wednesday, and Friday from 1 to 2 p.m. and those are on Zoom. So to join that office hour, you just wait for this time and then click this link and it'll launch a Zoom meeting just like the one we're in right now. Except that Zoom meeting has a waiting room because people sometimes like to discuss private things in office hours, want to talk about grades or something that's going on in their life. So I've got the waiting room enabled there. That way everybody can have the privacy they deserve. All right, first thing I'm going to actually ask you guys to do, get out your phone, go to your calendar app, serious right now, get out your phone, go to your calendar app and put this in. Your final exam is December 9th at 10:30. So that's not the time we normally meet, right? And I think December 9th, I want to say that's a Thursday or a Friday. Let's see. All right, it's a Thursday. So it is a day that we would normally have class, even though it's a week after our last day of class. It's an easy thing to mess up. I really don't want that to happen to any of you. So please, please, please put this in your calendar right now. All right, we are going to talk about WebAssign in just a minute, but before we do that, I'm going to go through the syllabus with you guys a little bit. Before we do that, I want to show you how to access the tutoring. So tutoring is a really good thing. Tutoring is not something you should be hesitant or ashamed to go seek out. Talking about this shit with somebody else is by far the best way to get it like into your brain. Think about the things you love doing. Think about the things that you know well. They're things that you talk about with people. And the same is true of mathematics. The more you talk about it, the better it will sit in your brain. So even if you are a mathematical badass and you have no problems with any of this stuff, I still recommend visiting tutoring at least once per like exam period, just to have that opportunity to have a conversation with somebody who knows it a little bit better and see if there's any place that you could improve your skills. If you don't want to go to the physical in-person tutoring, there is online tutoring, and I'll show you how to get to both of those things here. Follow the link that I have there in Canvas for you. Then scroll down to Northwest Campus Math and Statistics. And then they've got the hours here. So if you want to go in person to the library at the Northwest Campus, that's the main Santa Fe campus, you can do that during any of these times. And there will be people there to help you with math. If you want to meet with them online through Zoom, they're getting better and better at managing the technical side of that. They have slightly more hours. They're slightly extended hours through the week. These are those. To actually get to the online tutoring, what you're going to do is go to this link right here. Click that. And then Math, Sciences, and Business Tutoring right here, the third button. Click that. And then you'd click this guy right here. This will load you into another Zoom waiting room. Somebody will come in and ask you, hey, what do you need help with? Is it calc? Is it college algebra? You say, yeah, I need help with pre-calculus. And they'll match you up with a tutor, and then you guys will go into a separate room. Right, so that's how you get to the online tutoring. The in-person tutoring, obviously, you just show up at the library at any of these times, and the tutors there will be more than happy to help you. I can specifically recommend Alejandro. He's probably swamped because I say this to all my classes, but of all the tutors that I've seen work there, Alejandro is by far the strongest. He is not only brilliant with mathematics, but he's a very good communicator of mathematics. So if you're looking for a particular person, I recommend him. Okay. Coming back over here to our Canvas page, the next thing I would actually like you guys to physically do with me today, first thing, of course, you put this in your phones, right? Everybody put this in their phone calendar, 1 or 2 notifications the day before, 1 early that morning. Next thing I'm going to ask you to actually do along with me here today is to click this link, click here to access the full course syllabus, and save it. You'll have the opportunity to open it in your browser, or open it with something else, or save it locally on your machine, save it so you can get to it. If you've not already created a folder for this class, please create a folder for this class. I recommend like a semester folder and then a folder for each class that you're teaching, or sorry, each class you're taking. Within here, I already have a copy saved, so I'll just save over that. But please save a copy of the syllabus to your computer. That way you can pull it up if your internet is out or whatever, don't have issues. I'm going to open it in Sumatra. All right, so this is the syllabus for our course, and I know nobody likes doing this, so I'm going to try to go through this somewhat quickly. I don't want to bore you. My name is John Fausticker. I'm technically an assistant professor here at Santa Fe. My office is A031D. That's downstairs on the north side of building A. It doesn't really matter because I'm not there. My phone number is this. This is technically my office number, but during daytime hours, I do have it set up to forward to my cell phone, so you can get a hold of me through this, but I am not able to check voicemail or get caller ID with this. So if you call this number and you don't get a hold of me, I'm not going to know you called. The best way for you to get a hold of me by far is email or Canvas messages. You can click this link right here. It's a mail to link. It'll pop up in your mail client, or you can send me a Canvas message. Canvas messages are actually better because Canvas messages tell me like which class and which section you're from in the subject line. So if you're going to send me a direct email, I'll ask you to do two things. First, send it from your Santa Fe email address. Don't send it from your Gmail. I'm not allowed to reply to those. So if you're going to email me directly, use your Santa Fe email. The second thing, please tell me the course and section number in the subject. So say MAC1140.008. So I know which class and section you're from. That way I can file things and I know who I'm talking to and I know what dates and things are relevant to our conversation. But again, Canvas messages, best way to get a hold of me. Just use Canvas. Class meetings Tuesday, Thursday, 11 to 12:15. You know that. Monday, office hours Monday, Wednesday, Friday, 1 to 2 on Zoom or by appointment. So if you can't come to this office hour, just reach out to me and say, hey, I want to talk to you. If you can never come to this office hour, if this office hour just straight up doesn't work for you, I would like you to send me a Canvas message today because I'm considering adding a few more standing office hours. I want everybody to have the opportunity to come see me kind of at their leisure. The office hours are by default going to be virtual, but if you want to meet up in person, we can do that too. Again, it's just something you have to reach out to me and let me know. The only thing I'll ask is if you do want to meet in person on campus, you're gonna wear masks. I have a baby here and we're trying to be very careful with him. Again, the final exam is Thursday, December 9th at 10:30 a.m. It's a 2-hour test, and to get into this class, you need a C or better in college algebra or the equivalent score on the placement test. The textbook we're going to use is Stewart's Pre-Calculus. I'm going to show you what that looks like. Here's what that looks like. All right, this is focus. This is what the book looks like. It's an instructor's edition. Yours won't have this red bar down the bottom, but you don't need to buy a physical copy of the book. In fact, I wouldn't even necessarily recommend buying a physical copy of the book unless you can get one really cheap, because it's an expensive book and you have access to an electronic copy for free in WebAssign. Start talking about that in just a second. All right. So the only thing I actually need you to buy for this class, gotta actually cough up the money for it, is the WebAssign access code. I know these things kind of suck. They're like around $100. You can get financial aid to cover it if you get it at the bookstore. But you do need to get a WebAssign access code. Regardless of whether you have your WebAssign access code yet or not, you can still register for our class in WebAssign. So the only thing you actually need to register for this class in WebAssign is the class key, which I have right here. And make sure when you type it in, you don't include the space at the end. Just SF College space 1805 space 2904 and stop at the 4. To register for this class in WebAssign, again, go to Canvas, click here to access WebAssign for online homework. It's going to take you here. You can go to enter class key, or you can log in if you already have an account, just the normal thing. If you don't have your access code yet, right, this class key is not an access code. It's just the thing that tells WebAssign which course you're trying to enroll in, right? Like I've got 5 WebAssign courses that I'm running right now. You guys want to enroll in the WebAssign course for this class. The class key, SF College 1805-2904, is the unique identifier for this class. The access code is how you tell WebAssign, yeah, I paid for this shit. If you don't have your access code, at some step in the registration process, they will ask you for an access code. On that page, there will be a little link somewhere that says, click here to start trial access, or click here for temporary access. That will get you in. It'll last 2 weeks, and then they'll kick you out. So you need to buy an access code sometime in the next 2 weeks. Not just buy it, but you need to get it in your hands sometime in the next 2 weeks. If you already have it, that's great. Just go ahead and enter it as you register for the class. If you don't have it yet, that's okay. I still need you to register for the class today because there's homework out already. And then as soon as you do get your access code, put it in so you don't get kicked out. I'll show you the homework in a minute. Other materials. There is not a requirement for a calculator in this class. You do not need a calculator. I'll be writing all the problems very carefully to ensure that you never need a calculator. However, if you feel more comfortable having a calculator to check your arithmetic or whatnot, I totally get that. The only one that you're allowed to use is the TI-32XS, this guy. It's about $10 at Walmart. if you're someone who just feels better having a calculator to check your numbers, that's the one to get. No other calculators can be used on tests. No other calculators can be used on quizzes or any proctored assignments. So if you are someone who feels more comfy with one of these, this is the one to grab. If you find it somewhere cheaper, like I said, I think it's like 10, 12 bucks at Walmart. If you find it somewhere cheaper, please let me know. So I would love to be able to share that with other people. Specifically graphing calculators or calculators that can do symbolic stuff like the TI Inspire, definitely not allowed, very much not allowed. We are teaching you guys in this class, one of the main things we're learning in this class is how to graph functions by hand. We're going to get really good at graphing lots and lots and lots of different functions by hand. So graphing utilities are not allowed. The last thing you need, which probably everybody here has because you're here, is a computer. I'll ask that you keep your web browser up to date. So whether you're using Safari, Chrome, Firefox, whatever, if it asks to update, let it update. If you don't update your browser, you can run into trouble with HonorLock. You can run into trouble with Zoom or other apps that make use of the browser. You need consistent internet access, and this is a sensitive one. For example, at my house, I moved like about 8 months ago. I moved into the house I'm in right now, and the internet was great for the first like 3 months, and then it went to shit. I don't know what happened, but it just stopped working. Like I would get drops about every hour, and those drops would last about 15 minutes. So I use my phone as a backup. I use the hotspot here in case I run into trouble. You need a backup too. If your regular internet access, whatever you're using, is not rock solid, 100% consistent, think of a backup. Have one in mind. It can be the hotspot on your phone. It can be the coffee shop up the street. It can be driving to campus. But specifically on days where we're doing an exam or something like that, you really don't want to get booted out because your internet goes down and not have a way to get back in. So keep your browser up to date. Make sure you have consistent internet access or a good backup. You also need a webcam. HonorLock is one of the tools we'll be using to proctor tests in this class. That requires that you have a webcam. I also, it's not listed here, I also need you to have a smartphone. I know everybody does, but you need a phone that can run Zoom, because on the day of the test, in addition to using HonorLock, I'm going to require you guys to set Zoom up off to the side where I can see your desk, your hands, your lap, the paper you're writing on, all that stuff. And I'm going to be very, very picky about that. I'll talk more about how we're proctoring tests when we get a little bit closer to it. So those are the materials you need. You don't actually need the textbook, but if you want it, this is it. You do need a WebAssign access code. If you don't have one yet, you can still register in WebAssign, and I need everybody to register in WebAssign today. But you'll need to get an access code within the next couple of weeks, otherwise you will get kicked out of the class in WebAssign. You don't need a calculator, but if you want one, this is the only one that's allowed. And technology-wise, you need a computer with good internet access, a working webcam, and a smartphone. Alrighty, course description. This class, along with MAC1140, which is trigonometry, is going to get you ready to take the calculus classes. That means we're going to be focusing a lot on functions. We're going to look at their graphs. We're going to look at their properties. We're going to learn how to solve equations involving these functions. But the main thing is going to be an emphasis on graphing. After we've kind of run through all of these different function types that we're going to study in detail, we will talk about conic sections, which are cool. Things like circles, ellipses, parabolas, hyperbolas. We're going to talk about inequalities in some detail. Turns out inequalities can get a little bit complicated, and they're really important in calculus. So you need to learn how to solve complicated inequalities. We're going to talk about linear systems, systems of linear equations, and these things called matrices, which allow you to sort of abstract the concept of a linear system. Turns out matrices very, very cool. And then we're going to finish the course by talking about sequences and series. If you want to read the full list of course objectives, it's here. Just follow that link. Cell phone policy, not super relevant these days because we're all online right now. Just don't distract other people, right? The basic rule, don't use tech in a way that distracts other people in class. You may have noticed that there is a Discord server for this class. I posted a link in the announcements. So the Discord server is a great way for you guys to talk to each other and you know, ask for help with questions or bounce ideas off of one another. And I definitely encourage you to participate on the Discord server, even if you just want to complain about something, or if you're wondering when something is due, or if you want to talk about whatever with your classmates. The Discord server is a great place to do that. So here's the Discord for MAC1140, and you see people are already asking and answering questions about how to get into WebAssign and little things like that. But don't blow up the Discord during class. Same thing, like don't blow up the Zoom chat during class. If you want to ask a question, ask it by all means, but try to keep it focused, right? If everybody's getting messages in Zoom chat or on Discord or anywhere else during class, it can be a little bit distracting. So kind of the current version of the cell phone policy, just don't distract other people. Attendance. I am taking attendance every day. I use the Zoom logs to do this. So here's something to think about. When you sign into Zoom, please make sure you use the name that's on your Santa Fe ID, right? You won't get your financial aid until I mark you as having attended. And the way I'm taking attendance is through Zoom logs. So if you don't use your given name or the name that's on your Santa Fe ID in Zoom, I won't know that you've attended. So please, please make sure you use your name as it appears on your Santa Fe ID here in Zoom. There is no attendance component to the grade. You're not going to lose points for not showing up, but missing class is real fucking bad. Trust me on that. You want to be here. You want to be here to ask questions. There's so much stuff in this class. I guarantee you there's at least one or two whole topics that are going to be completely new to you. Maybe all the topics are completely new to you, but there will at least be one or two, and you really want to be there to ask questions. I do record the lectures. I will be posting the recorded lectures to YouTube every day after class, but that's no replacement for coming to class. You gotta come to class. In addition to that, I'll say that I do use the attendance to kind of help me with those tough decisions at the end of the semester. If somebody is asking for an extra favor, like can I turn in all these homework assignments after the final, something like that, that normally I would say absolutely no to. If you've come to every single class, your attendance is awesome, you really care about the class, I might be willing to bend a little bit more for you than I would if you never show up. So no grade component to the attendance, but showing up is one of the ways you let me know that you care. And it's also the best way for you to make sure you don't fall behind or miss important information or all that stuff, right? Come to class. This is college. Come to class. Don't miss class. You're paying for this shit. You're paying a lot of money for this shit. Don't miss class. Makeup policy. I'm pretty relaxed about homework. So if a homework goes by and you're not happy with how much of it you got done or anything like that, you can submit an extension request within WebAssign, and 99.9% of the time I will grant that, no questions asked. I'll give you an extra 2 or 3 days or maybe an extra week. So don't stress about asking for extensions on the homework. At the same time, don't fall behind on the homework. Falling behind on the homework is a killer in this class. You need to stay on top of shit. But if once or twice you get the thing to like 80%, you really want that extra 20%, submit an extension request, I'll give it to you, no doubt. Exams are more complicated. If you know you're gonna miss a test, you need to talk to me ahead of time. Like it's a religious holiday or you're gonna be out of town or anything like that, you need to let me know ahead of time. If you miss an exam because there's something that happens on that day and you can't do anything about it, a flat tire or you get sick or something like that, just let me know as soon as you can, and I'll schedule a makeup for you. I'm not going to require you to get a doctor's note. You guys are all grown-ups. Talk to me and we'll get you scheduled for the makeup. I usually do 1 makeup session per exam, and it's always within 1 week of the original test. So that's the thing, just communicate with me, right? Let me know what's going on, I'll work with you. I want you to take the tests, right? I would much rather you take the test than not take the test. I don't really care why you missed it, I just want you to take it. The last day I'm gonna take any graded material is the day of the final, right? So that's the thing I was mentioning above. So homework, gotta be done by the final, all the quizzes gotta be done by the final. I'm not gonna grant any extensions beyond the day of the final, barring some extreme circumstances. Speaking of homework, each week there's going to be I've got 2 homework sets in here right now. This is what I did last semester. I'm kind of on the fence between going back to 1 homework set per week or doing 2 homework sets per week. Right now I'm leaning towards 2 homework sets per week. You'll have 1 due on Tuesday and 1 due on Thursday. So every day we have class, you are going to have a homework set due. And that homework set is going to be due at the start of class. So for example, there's a homework set that's open right now. Normally that would be due on Thursday at the start of class. So I want you to work those problems before the next class meeting so that everybody's on the same page and learn that shit so we can move on. That's the idea. 2 homework sets per week. They are due at the start of class on each day. Oh, this is Monday and Wednesday. Sorry, because that last class was a Monday, Wednesday class. So for you, it's going to be Tuesday and Thursday. There's going to be about 1 quiz per week, maybe a little bit less. Those are also going to be in WebAssign, and they'll be due on Tuesdays. I'm sorry about this, guys. I need to change this. So Mondays, go to Tuesdays. Wednesdays, go to Thursdays. Basically, just pay attention to the due dates in WebAssign. There are 4 exams and 1 final. The 4 midterm exams, we'll talk about when those are going to happen and what's going to be on them in a little bit, are going to be done in class, during class time. And the way we're going to proctor them is how I described at the start of our lesson here. You're going to use HonorLock on your computer, and you're also going to use Zoom on your phone. The way this is going to go, you're going to sign into a Zoom link on your phone. You're going to set up your phone off to the side of your desk or above you or somewhere. I can see your desk, your paper, your hands, your lap, all the places that I would want to see to make sure there isn't a phone or cheat sheet or somebody hiding under your desk, shit like that. Just trying to keep things a little bit secure. If you don't have a smartphone that can run Zoom or something like that, let me know. I can get you one. But I think pretty much everybody has at least one smartphone these days. The final exam is going to be proctored the same way. It's just longer and during finals week. So that's what this is, talking about Zoom and HonorLock proctoring. Exams take place during normal class hours. That's what it means to be a hybrid class rather than a fully online class. A hybrid class, we have a set meeting time and the exams take place during that set meeting time. So again, just to try and have a little bit of security. Again, the final is 12/9 at 10:30. Please, please, please don't miss that. Alrighty, moving on. Recording notice, right? So I love that you guys have your cams on. That really makes me happy because I want to see your faces. I want to get to know you. That's really good. Just be aware that I do record the meetings and I do post them to YouTube afterwards so you guys can review them for your notes. And if your cam is on, that means you'll be included in that recording. Just a little thumbnail on the side. So, be aware of what you're wearing, be aware of what's going on behind you. I had a kid leave his 4-foot-tall dab rig out right behind him for every class session over the summer. That was kind of funny. When he discovered that those were in the videos, he was probably a little bit nervous. I would be. So, just be aware of what's going on. Important dates, some other things you might want to put in your phone's calendar. Obviously, when classes begin. The last day to add a class is tomorrow, the 25th. The last day to drop and get your money back is the 27th. So if you decide you want to bail on this class, you don't like the format, or it's just not something that you want to do right now, the last day you can get out of here, get your money back and nothing on your transcript, that's the 27th. The last day to add is before that. So you would want to think if you're going to add another class to replace this, you need to add that class before you drop this one, or at least the deadline is before the drop deadline. So just be aware of these. These are things that can catch you out. Labor Day is September 6th. The college will be closed for that. We're also closed for UF Homecoming for who the fuck knows why on October 1st. The 2nd of November is the last day to get a W. So similar to the drop day, last day to drop, this means you get your money on 8/27, you get your money back and nothing on your transcript. If you go past that day, then your next opportunity to bail, or your next last opportunity to bail is November 2nd. And if you bail between those two, you'll get a W on your transcript and you don't get your money back. If you want to bail on the class after November 2nd, you need to go through the petitions process. And the petitions committee is pretty understanding. You'll often get those late withdrawals if you apply for them, but it's a little bit more of a hassle. So I really encourage you guys around this date to take a close look at your grades, specifically the exam grades, and see where you are, how things are going. If you think you're going to earn the grade that you need to earn in this class, talk to me, please. Come talk to me in office hours and I'll help you make that decision. But things get harder beyond November 2nd. So that's a good day to kind of recap how the semester has gone and make a decision. Other holidays, on the 11th of November, we're closed for Veterans Day. On the 25th and 26th of November, we're closed for Thanksgiving. That's just the Thursday and Friday, I believe. Wednesday, we are still having class, although this is a Tuesday, Thursday class, so that doesn't matter. Last day of class for you is December 2nd. Your final, again, is December 9th, and then your grades will be posted no later than December 14th in East Santa Fe. Speaking of grades, here's where they come from. Most of the grades come from the exams, and then there's also a cumulative final. It's not quite worth 26% anymore because I added another midterm. We used to just do 3 midterms. So here's the actual breakdown, right? The homework on the point system, it's 45 points, about 7% of the overall grade. The quizzes and labs, not doing labs right now because we're not meeting in person in the lab. Quizzes are 75 points, which is about 11% of the grade. The midterm exams altogether, 400 points. There's 4 of them. They're 100 points each. They're worth about 60% of the grade. And then the final exam is worth 1.5 midterms, 150 points, and that's about 22% of the grade. So whether you want to go by points or percentages is up to you. The total is 670 points. The breakdown is here. Grading scale uses the normal one. 90 to 100 is an A, and it goes down by 10 points. So like 80 to 89 is a B, 70 to 79 is a C, and so on. If you're in the top 3 points of any one of those categories, you get the plus designation. So an 87, 88, 89, that's a B plus. 77, 78, 79, that's a C plus. People always ask me at the end of the semester, if I'm at like a 79.5, do I get a B? Yes, yes, you do. Here's my rule. If you're within 1.5%, then I will round you up to the next letter grade, right? So a 78.5 is a B. A 78.4, still a C plus. That's the rule. The next page is pretty much boilerplate syllabus stuff. Every syllabus at Santa Fe has to have this. GELOs, General Education Learning Outcomes. There are specific questions on tests that I will be using to track my yeah, hey baby, be using to track my success as your teacher. These don't have anything to do with your grade. They are just statistics that the state asks us to track. They won't show up in your transcript or anywhere else, but I have to let you know that there are some quantitative reasoning questions that will show up on your exams. They might have a little G next to them for GELO, and those are the problems that I'm using to track those statistics for my own purposes. Academic integrity is a really big deal, especially online. I'm going to talk more about this in a little bit, but there are pretty clear rules about what you're allowed to do and what you're not allowed to do. It's all fairly intuitive, but if you've never read them, you should really follow this link and read them. If you step out of line in one of these ways, then these are the rules that you're going to have to answer to in the conduct trial. And believe me, those happen a lot these days. Very busy with conduct trials. So I encourage you to read these rules, or at least skim them so you have some idea of the rules that you will be judged against. The American with Disabilities Act, the ADA, is a really good law that is basically there to make sure that everybody has equal access to media and things. So if you have any sort of disability, whether it's a learning disability or a physical disability, anything like that, let me know, regardless of whether you're registered with the DRC. I know it says you must be registered with the DRC, but even if you're not, if you think you might qualify to work with the DRC, let me know and I'll figure out some accommodations for you. We don't have to go through the DRC, especially if you've like just applied or just filed paperwork with the DRC. They can take their time getting that shit sorted out. And I don't want you to not have the accommodations you deserve just because the DRC is slow with paperwork. So if you're registered with the DRC, or you think you may qualify for any sort of testing accommodations, extra time, or a quieter environment, or anything like that, note takers, anything at all, just let me know and we'll get it figured out, I promise. Accessibility is along the same lines. All the documents that I publish for this class are going to be written in the LaTeX markup language, published as PDFs. I also use LaTeX when I publish things to Canvas, which means it all works really well with screen readers. So if you have any issues with vision, hearing, any stuff like that, my materials should work well with the majority of software that's out there. If you have any trouble with anything like that, let me know and also talk to the DRC. We'll get it figured out. I want to make sure you guys can access all the materials that you need in a way that you can understand them. Discrimination and harassment, this should go without saying. Just don't be an asshole, right? Be decent to each other, be decent to me, be decent to anybody who works here at Santa Fe. In general, just be decent, period. But you know, especially to your peers and colleagues and professors. Student rights and responsibilities, this is kind of similar to the academic integrity thing. I strongly encourage you to take a look at this, at least skim this link so you know the sort of standards that you're being judged by. Okay, and then this bottom one here, this is the one I want to spend a little bit of extra time on. So I've been teaching at the college level for around 15 years, and I love it. I love it. But in the last year and a half, I've seen more cheating than I did in the 13 and a half years before that. I really abhor cheating. It's something that, well, I don't take it personally. I do have a personal vendetta against it. I know that right now it's more tempting than ever, right? I get it. You're taking a difficult class. It's online. When you take the tests, usually there isn't somebody physically in the room with you. And it's very easy to get into that headspace where you're starting to panic and think, okay, instead of continuing to study, I need to find which app I'm going to use to cheat on this test, or where I'm going to hide my phone, or where I'm going to tape the cheat sheet, or how I'm going to keep the camera pointed so they don't see or hear this other person that's in the room Googling shit for me. I'll start here. I have Photomath, MathWave, Wolfram, Symbolab, all installed on my phone. And I run my own shit through those apps. I know what the output from those apps look like. Over the summer, in a MAC1140 class, on one test, I caught 6 people cheating. 2 used Photomath and 4 used MathWave. One test. All 6 of them got in a pretty steaming heap of shit. All 6 of them got referred to the Student Affairs Office, Dan Rodkin. All 6 of them had to go through conduct trials. My record is 9 on one test. I caught 9 people cheating on one Calc 2 exam last fall. Every semester, I catch a bunch of people cheating. So I've added this little note to my syllabus. I get that it's tempting right now. I do. I get that these classes are hard, and I get that being at home or somewhere that's a little bit less, a little bit less monitored, makes it very, very tempting to try and cheat. I'm very good at catching cheaters. It's something that I don't like doing, but I've had to do because I want to preserve the value of your degrees. Your degree from Santa Fe won't mean shit if it gets out there in the world that everybody cheats their way through these classes. As soon as that's out there in the world, and believe me, it will get out there, it's getting out there already, the value of your degree goes down. That includes like the likelihood that universities will let you in. That includes like the value that employers will see in your degree in the future. That includes the value of your transcript in general, anywhere you would want to use it in the future. The more people cheat, the less valuable that shit is. So I'm trying very hard to keep the value of your degree high by fighting this cheating. It's not something I'm doing to hurt you. It's something I'm doing to try and help you. So here's the deal, right? I know these things. Don't try and use them. I'll catch you. If you start to feel tempted, if you get into that headspace where you're starting to think, well, what app should I use on my phone? Or where should I tape the sheet? Or how should I hide this person from the camera? Or how can I talk to this dude in the other room? I've seen all of it. If you're starting to think like that, instead of going through with it, just send me an email. Just send me a Canvas message saying, I'm stressed. This test is coming up and I'm not in the place I need to be for it. I'm stressed out, help. And you know what I'll do? I'll fucking help you. I will, right? Whether that, if it's early enough, then we can do some one-on-one office hours. I can get you some private tutoring. I can get you extra worksheets and resources. If it's really close to the test and there's no time to really fill in those gaps, I'll move the fucking test for you, right? If somebody could lie and say they're sick, somebody could lie and say that they got a flat tire. I get it, shit like that happens. I would much rather you just tell me I'm stressed, I can't, I'm not ready for this, and I'll put you in the group for the makeup test a week later. Talk to me. Please, please talk to me. Don't cheat. If you cheat, I'll set you on fire and run you up the tallest pole. I swear to God, I will. Dan Rodkin has had so many people in his office because of me. I'm not at all shy about doing that. But if you reach out to me and let me know that you're in this situation where things aren't going well, you don't have to say I'm thinking about cheating. Just, I swear I won't think less of you. Just let me know that you're in that situation where you're not feeling good about the test, and I will work with you. I'll do whatever I have to do to help you get where you need to be for the test. I promise. I will do everything I can, but I will not tolerate cheating. And I will catch it. All right. Sorry about that. I know that's a little bit unpleasant. Here's the rest of the good stuff. So the course calendar, it's going to go like this. I may change some of these things depending on how quickly you guys are getting through the homework, or depending on how comfy you seem with the material. We may slow down a little bit if you're having a hard time. We may speed up if everybody's going through it really great. The first week, we're going to go through chapter 1, which is all preliminary stuff, and we're going to go through the first 2 sections of chapter 2, which is just like, what is a function? Here's some different ways of thinking about functions, and trying to get you to understand what a graph of a function really is. things, which is a big step here. Believe me, there's 2.2 stuff that people will get wrong on the exam. Today, we're going to start on the chapter 1 stuff. After that, we're going to go through the majority of the textbook. Exam 1 is going to cover the material up to section 2.8, which is on one-to-one functions and their inverses. That's when we're going to begin this detailed study of different families of functions. After we've covered those sort of basics on functions up through 2.8, we're going to start talking about polynomial functions and rational functions. We're going to learn a lot about polynomials, like how to divide them. We're going to learn some theorems on their x-intercepts or roots. Give you lots and lots of tricks for factoring, lots and lots of tricks for graphing. And then we're going to start talking about rational functions, where again, I'll give you lots and lots of tricks for graphing, and then you're going to learn about inequalities involving those specific kinds of functions, and that will be the material that's on exam 2. After that, we're going to start talking about exponential functions. These are functions where the variable is in the power. We'll cover the natural exponential function, e to the x. We'll cover logarithms, the inverses of those functions. We'll talk about the algebraic properties of logs, and then we'll learn how to solve equations and do modeling with those. Then we'll be ready for exam 3. After that, we're going to start talking about systems of equations. You've seen these sort of things, usually solve them with substitution or solve them with elimination. We're very quickly going to go over the sort of stuff that you learned in your previous algebra classes, and then I'm going to show you how grown-ups handle systems of equations, i.e. matrices. After introducing matrices as a concept through linear equations, we are going to talk about the algebra of matrices. Turns out matrices, kind of like numbers, there is an algebra you can do with them. It's awesome. We'll talk about matrix inverses, determinants in Cramer's rule, and then one really important application called partial fractions, and then we'll be ready for exam 4. The last bit of the class covers sequences and series, and then conic sections, and those will be tested only on the final. All right, that's the course. Do you guys have any syllabus questions for me? Any questions about the class policies? Okay. And then again, I just want to reiterate, I need everybody into WebAssign today. The only thing you need to get in there is this class key. The class key is not the same as the access code. You do still need to buy an access code, but even if you don't have one, you can still get into the class. I'm going to show you what the WebAssign class looks like for us right now. All right, so you do have one homework set up already in WebAssign. It is not a short homework set. It's going to take some time. So I strongly encourage you get in there. All right, here's our class, MAC1140, section 008. Here's your first homework. All right, you'll see it's got 37 problems, almost 40 problems. And they're, basic things like what sort of things are natural numbers, what sort of things are integers, how do you add, subtract, multiply, and divide fractions, basics of inequalities, basics of like roots and exponents, some stuff involving domains, some stuff that you should know from basic algebra classes in the past. A little bit on interval notation and solving inequalities, just fundamental stuff. We're going to cover this stuff this week. And that is due next Tuesday at the start of class. All right, so you've got 1 week to knock that out. Normally this would be due on Thursday, but I know it's going to take some time for everybody to get into class, get registered and stuff. I can't have a homework be due on the last day you can add classes. That would be shitty. So this first homework, which just covers chapter 1, the preliminaries, which is all stuff that you should have seen in previous classes, is due next Tuesday at the start of class. I will be posting another homework set on Thursday, and that will also be due next Tuesday at the start of class. All righty. So with all that out of the way, let's do some friggin' math, yeah? All right. So this is just preliminary stuff. We're going to start by talking about number systems. People like to think that numbers are like somehow God-given or something like that, that they've been around forever and that they've always been understood or something, which is totally not the case. The number system that we work with, the real number system, at least for the most part, sometimes complex numbers, the real numbers are a fairly new construct. The Greeks certainly did not know about the real numbers. In fact, the Enlightenment era thinkers like Galileo did not know about the real numbers. The first person to have a concrete understanding of what the real line is was a man named Richard Dedekind. And he was around Cauchy's time, late 1700s, around the time of the American Revolution. Before then, the other number systems that were considered and are certainly still relevant today, the first one just has 0, 1, 2, 3, and so on. This is a number system that was acknowledged by, I want to say cavemen, but certainly the Greeks. These are called the natural numbers. Natural because they're the counting numbers, right? You can have 0 of something, you can have 1 of something, you can have 2 of something. So these are called the natural numbers. And a fun fact, depending on where you are in the world, some people include 0 in this, some people don't. For example, in France, mathematicians in France would say 0 is a natural number. Mathematicians in Germany would say 0 is not a natural number. There is a symbol to refer to this set as a singular object, right? You'll notice that I've got these things in curly braces. In mathematics, when you see a bunch of stuff listed inside those curly braces, that is the set containing these things. So think of the curly braces as like a box, right? This is the box into which I put the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, blah, blah, blah. The symbol that I use if I want to refer to this set as a singular object is a blackboard bold N. As people's understanding of mathematics evolved, we started realizing, well, I can subtract numbers. And pretty quickly, that shows you need some concept of a negative number. So if you take the natural numbers and then you include the negative versions of all of those, you get something called the integers. And the symbol that I'll use if I want to refer to these as a single object is a blackboard bold Z. That Z stands for the word Zahlen, which is German for number. Kind of the next step up in complexity, if you want to do more and more algebra with your number systems, I can add, subtract, and multiply anything from this set, and I'll get another thing from that set. If you multiply 2 integers, you get another integer. You add 2 integers, you get another integer. But if I start dividing these things, then pretty quickly I get something that is not an integer. And so if I want a place where I can do division, then I'm talking about all the fractions where m and n are integers. This set has a special name. Does anybody know the name of this set down at the bottom here? The set of all fractions of whole numbers?
Rational numbers.
Yeah, excellent. These are the rationals. And the symbol to refer to that set as a singular object is a blackboard bold Q, Q for quotient. All right, but none of these are the number system that we're going to use. The number system that we're going to use is a little bit more complicated than even this. Does anybody know a number that is not a rational number?
Pi?
Yeah, very good. Pi, that was Jesse, right? Pi is a not rational number. It's called an irrational number. The square root of 2 is also an irrational number. In fact, if you take the square root of any number that is not itself a perfect square, the result is an irrational number. E is another irrational number. So if you take all the rational numbers kind of together with, that's the union symbol, right? It means to throw these together with the irrational numbers. You get something new called the real numbers. And the symbol I use to refer to this set is a Blackboard bold R. Another way to think of this is it's all possible decimal numbers, right? Any possible decimal expansion, whether it's finite or not, whether it repeats or not, is a real number. So the real numbers are the set that we're going to work with for the most part. When I'm asking, what are all the numbers between 0 and 1? If I was just talking about natural numbers, there are no numbers between 0 and 1. If I'm talking about integers, there are no numbers between 0 and 1. If I'm talking about rational numbers, now all of a sudden there's infinitely many numbers between 0 and 1, but they're all nice fractions. If I'm talking about real numbers, then again, there's infinitely many numbers between 0 and 1. Some of them are nice fractions, but there's even more irrational numbers in there. All right, so these are the number system we're going to use. Almost exclusively with real numbers. So when I write down a variable, you can understand that that variable represents a real number, unless we explicitly say otherwise. Like sometimes we'll work with complex numbers. Some facts about the real numbers. They are ordered. They are complete. And they are a field. Right? So this is actually one of the things that analysts, a particular kind of mathematician, would say that the real numbers are the unique, complete, totally ordered field. I'm going to tell you what each of these things means because I want you to, when you think about the real number line, I want you to have these things in mind. So by ordered, what we mean is they can be arranged on a line. In fact, all of the number systems I described over there are ordered. In particular here, if you want to be fancy about it, well, if you have two real numbers that are not the same, one is bigger than the other. Either x is less than y or x is greater than y. All right, that's what it means to have a totally ordered set. If you have two different elements of that set, one of them is bigger. The complex numbers also have an order, but it's a partial order. All the other sets that we discussed there are totally ordered. Natural numbers and whole numbers, it depends on what you mean by whole numbers. So Christopher asked a question in the chat, are the natural numbers and whole numbers the same? Usually when people say whole numbers, they're referring to the integers because they want to consider negative numbers as whole numbers. But certainly every natural number is a whole number. But there are some whole numbers which may not be natural numbers, like -5 is not a natural number. But I would say -5 is still a whole number. But yeah, pretty much the same idea. Okay, when we say the real numbers are ordered, that means they can be put on a line, i.e. any two real numbers that are not equal to each other, one is bigger than the other. What do we mean when I say complete? Well, I mean there's no gaps on the line. In other words, if you picture the number line and you kind of throw a dart at it, no matter where that dart hits, you're going to hit a number. Another way of saying this is between any two real numbers, there are not just one, but actually infinitely many other real numbers. A final way of thinking about this is if you had the number line and you could like zoom in on it, no matter how far you zoom in, you'll never ever find a gap. The number line is solid. no gaps. This word complete is a special thing in analysis. Usually it's described in terms of sequences. Every sequence that's like trying to get closer and closer to something actually gets closer and closer to something. If you think about the rational numbers, for example, those are not complete. Picture putting the rational numbers all on a number line and then trying to zoom in on the square root of 2. Well, you know the square root of 2 is not a rational number. So as you zoom in on that, you're going to find a little gap right there at the square root of 2. The real numbers don't have that problem. So there are no gaps on the line. Between any two real numbers, there's infinitely many more real numbers. And then finally, they're a field. Now, a field is a special term from algebra. Well, this means given any x and y, we can form the sum, x plus y, the difference, x minus y, the product, x times y, and if y is not equal to 0, the quotient, x over y. And all of these are themselves real numbers. All right, the integers don't have this property. For example, if I add two integers, I do get another integer. If I subtract two integers, I do get another integer. If I multiply two integers, I do get another integer. But if I divide two integers, I might not get another integer, right? I might get something that's not an integer, like 1 divided by 2 is not an integer. Places where you can add, subtract, and multiply and stay in the set, those are called rings, and those are also very interesting. But we prefer to work in fields. Fields are places where you can do all the algebra. Interestingly, the rational numbers do form a field, but they're not complete. The rational numbers form an ordered field, but not a complete ordered field. And completeness is very, very important for calculus. Turns out this fact that the real line is solid is a big fucking deal when it comes to calculus. So we need the real numbers in order to do calculus. You can't do calculus on the rational numbers. You definitely can't do calculus on the integers or on the natural numbers because they're not even a field. So the real numbers are the unique place where we can kind of introduce calculus. They're the simplest number system on which calculus works precisely because they have these three properties. They are ordered, they are complete, and they are a field. And every time you think about the real line, I want you to remember specifically that between any two real numbers, there's infinitely many more real numbers. In other words, there is no next real number, right? If you think you have a number here and this one is the next one, well, then you've got two real numbers and between them is infinitely many more real numbers. So this couldn't possibly be the next real number. There is no next real number. The line is solid. Okay, that's my quick and dirty introduction to what the real numbers are. I have you guys for how much longer? Let's see what time we have here. 12:15. All right, that's just long enough for me to go over some rules for exponents. I am trusting that everybody remembers how to add, subtract, multiply, and divide numbers. I'm trusting that you all know how to add, subtract, multiply, and divide fractions. And I know that might actually be a little sticking point. That's why there's some of that stuff in your homework. But I'm going to start here with the actual material on rules for exponents. Next time we'll look at some examples of how to combine fractions and stuff. But I know a lot of people forget this stuff. So if I take a real number a, I raise it to some power, and then I multiply that by a raised to some other power, that's the same as taking a and raising it to the sum of those powers. There's a version of this for division. If you divide like bases, then you subtract the powers. There's also a neat rule for raising a power to a power. So if you take something like 3 squared and you raise that to the 5th power, that's the same as taking 3 and raising it to the 2 times 5, or sorry, n times m. So if you raise a power to a power, you multiply the powers. All right, some other stuff. If you take a number and you raise it to a negative power, that's the same as the reciprocal of that number to the positive version of that power. There's a lot of ways to get this wrong, so be careful with it. If you take a number and you raise it to a power like 1/2 or 1/3 or 1/4, that's the same as taking the square root or 3rd root or 4th root of that number. And then finally, if you take a number and you raise it to a fraction that's a little more complicated, like 5/7, there's 2 ways you can think of this. That is the nth root of a to the m, like this, or the nth root of a all to the m, like this. Okay, so these are some basic rules for exponents. There's one more that I'm going to tuck up here, and that's that if you take a product, 2 things multiplied, and you raise them to some power, this only works for multiplication. That's the same as a to that power times b to that power. All right, so these are your basic rules for exponents, and you're going to be using these all semester long. So let's take something and work with it a little bit. Let's see if we can apply these rules a little bit.
Could you go back to the paper for like 1 second, please? Thank you, sorry.
Yeah, no, it's okay. Never worry about asking that. Always happy to do it.
Also, quickly, I have 2 questions.
Sure.
So for the complete, like the complete numbers, I don't understand like why rational numbers like can't be complete. Like I don't get that.
It's a very good question. So the fact that, how do I want to say this? The rational numbers don't satisfy this. They do actually satisfy between any 2 rationals. There's infinitely many other rationals. But
Okay.
so yeah, it is true that between any 2 rationals, there are infinitely many other rationals. That's not equivalent to complete. That's a consequence of being complete. So the reals have that property, so do the rationals. But there are gaps in the rational numbers. I'm trying to think of a nice way to explain this. If you take the real number line and you put a little dot on every single rational number, an infinitely small little say yellow dot on each rational number, and then you pull away the real line so you just have the dots, there would actually be gaps between the dots. There'd be very, very, very small gaps, infinitely narrow gaps. We couldn't even see them, but they're there. So the way my first-year graduate analysis professor would put this is you should think of the rational numbers as a sprinkling of dust along the real line. Kind of everywhere you look, you're going to see some, but they're not touching each other. They're not right up against each other. So the real numbers are right up against one another and form something solid. And the rationals are kind of like a faint sprinkling of dust along the real line. The easiest way to see that the rational numbers are not complete is to ask, are there any numbers that are not rational? So like if I look at the real line, can I find anything on there that isn't a rational number? If there is, then I could pull that out. I still have all the rationals, and now you've got a gap, right?
Yeah.
And one of the first numbers that was proved to be irrational is the square root of 2. I'll prove that for you later in the semester, that the square root of 2 is an irrational number. So imagine you take your real line, you pluck out the square root of 2. You haven't taken away any rational numbers yet, because the square root of 2 is irrational, but you have created a gap. So there are these very, very, very small gaps in the rational numbers. There's actually a lot of them. Any square root of a non-perfect square number, any power of e or pi that is itself an integer or rational would be irrational. So that's the sense in which the rationals are not complete, but it's not an obvious thing. It's kind of hard to get there unless you think very carefully about it. I hope that helps.
Okay, thank you.
Sure. Any other questions so far? Okay, let's play around with some of these rules for exponents then real quick. I'll just do one or two quick examples here. So simplify. How about the third root of x to the 3/2 times a to the 9? Yeah, why not? We'll start there. 1 over the square root of x times the square root of x, like this. And let's do one more. Let's do something involving some fractions, like something like this. Just get us a little bit of practice with all of these things. The bottom one, of course, this is not practice with exponent rules. This is just something I want to play with, make sure we're comfy with. For these top two, we're going to use those exponent rules for, okay? Can anybody help me with the first guy? So this is the cube root of x to the 3/2 times a to the 9. I've got this page up, but you guys should have that page of exponent rules up and see what we can apply from that. Is there anything from that list of exponent rules that jumps out at you as something we could do here?
The exponent rule a to the m divided by n is.
We could use that to rewrite this as a root. That's an option. But I want to actually go in the other way. I want to rewrite everything as a power and then see if I can clean up those powers. And then at the end, we'll rewrite as roots. So we are going to use that, but only at the very end. What about this big root outside? Can I do something about that? Can I rewrite this? I'll write the solutions here in purple. I'll leave the inside alone, x to the 3/2 times a to the 9. Can I write this cube root as a power? And if so, what would it look like?
Could you make it like a power of the entire equation?
Good. Yeah, I'm going to say, okay, all of this stuff was under the cube root. So all of that stuff is going to be raised to the equivalent power. What power is equivalent to the cube root?
1/3.
1/3. Very good. All right. Now I've got two things multiplied together, all being raised to a power. So which of those rules can I use here?
Would it be the last one you showed us where it's
Very good.
a, b to raise to the n?
Yeah, if I take a product of two things raised to the n, then I can raise each one of those things to the n. This only works with multiplication. It does not work with addition or subtraction. It works with multiplication and division. So here my first thing is x to the 3/2. So I'll have x to the 3/2 all raised to the 1/3. And I'm going to use parens because it's a power raised to a power times. And then I've got a to the 9 all raised to the 1/3. Does everybody see what we did there? I'm giving this 1/3 power to each of the two pieces inside the parens. And that gives me two pieces, each of which is a power of a power. So what rule can I use to simplify that first piece? I'll come down over here.
Could we multiply each of the powers with each other?
Perfect, right? If I take something raised to a power, and then I raise that whole thing to another power, we just multiply the powers. So this is, the first piece is x to the 3/2 times 1/3. And I'll go ahead and do the same thing with the other piece. That other piece is going to be a to the 9 times 1/3. And now we're almost done. What is the power in the first piece? What is 3/2 times 1/3? Remember how we multiply fractions? We can multiply straight across. So this is 3 times 1 over 2 times 3.
Would it be 1/2?
Yeah, very good. It's 1/2. You can think of it as 3/6 like that. Or because these fractions are multiplying, you can cancel the common factor of 3 top to bottom. And you realize, oh, it's just x to the 1/2. So that first piece is x to the 1/2. And the second piece, same sort of thing. I've got 9 over 1 times 1 over 3. That's 9 over 3, or just 3. So this is a cubed here. And then if we wanted to, we could rewrite this using square roots. I would write the a cubed out front to make clear that it's not in the root. And then x to the 1/2 is the square root of x. So this scary looking expression is actually the same as a cubed times the square root of x. Any questions on any of those steps here?
Professor John,
Mhm.
I know that you said that these recordings go on YouTube. Are we able to access them for when we go and do our homework later?
Yep. Yeah, so what I'll be doing is uploading this to YouTube right after class, and then I'll post the YouTube link to the same announcement that you went to for the Zoom link, and then you can watch it whenever you want.
Okay, thank you.
All right, any ideas how we can start on the second one on part B here? We're a little short on time, so let me show you what I would do. I would start by rewriting these roots as powers. So this is 1 over parentheses x times x to the 1/2, all raised to the 1/2. So the big square root is the big parentheses 1/2 power, and the little square root inside the square root of x is this little x to the 1/2. Now, if I follow my order of operations, I should clean up whatever is inside the parentheses first. So I'll still have my 1 over, and then the big parens with the 1/2 power outside, x times x to the 1/2. How do I simplify that? Remember, x is x to the 1.
Would you multiply them?
So I'm multiplying the bases, which means I do what to the powers?
Add them?
Yeah, very good. That's this rule, right? So x to the 1 times x to the 1/2 is the same as x to the 1 plus 1/2. What is 1 plus 1/2?
1.
1 plus 1/2.
1 and 1/2?
1 and 1/2.
Yeah, 1 and 1/2. How do I say that as a single fraction though?
3 1/2.
3/2, yeah.
3
So I write
halves,
the
yeah.
1 as 2 over 2, 2 over 2 plus 1 over 2. Now we have a common denominator, so we can add the numerators, we get 3 over 2. So the thing inside the parentheses here is x to the 3/2. And now I've got a power raised to a power. So I'll multiply those powers. 3/2 times 1/2, that's 3 times 1 over 2 times 2, that's 3/4. So this is x to the 3/4. And then finally, I can bring that upstairs as x to the negative 3/4 if I want to. All right, let's do this last one and then I'll let you guys go. Fractions can be a little bit weird because division is not associative. It's definitely not commutative. It's not even associative. So this big fraction bar, you should always think of this as parentheses. Parentheses. Fractions always come with these built-in parentheses. So the top is just 1/2 and the bottom is 2 plus 1/3. If I'm going to clean this up, I need to follow my order of operations. Take care of the stuff inside the parens first. 2 plus 1/3, the only way to simplify that is like we did over here. You got to have a common denominator. So the 1/3 I'll leave alone, but how do I write 2 as a fraction with downstairs 3? Well, I multiply by 3/3, and that becomes 6/3. All right, I think everybody agrees 6/3 is the same as 2, but we need to write 2 as 6/3 in order to add those fractions, and because of these parens, that's what we must do first. So now I've got 1/2 divided by 6/3 plus 1/3 is 7/3. And again, you see I'm using parentheses and a big long fraction bar. Unless you use that big long fraction bar to make clear what's the big top and what's the big bottom, the statement doesn't even make sense. So it's important that you're careful with your kind of length of fraction bar and your parentheses. Fractions are a little bit weird unless you are careful with these things. Finally, now I'm dividing two fractions. I've got 1/2 and I'm dividing it by 7/3. We all know how to do that. You take the top, leave it alone, and flip and multiply by the bottom. So we're going to multiply 1/2 by 3/7. And then we multiply these fractions straight across. 1 times 3 is 3. 2 times 7 is 14. So this whole mess here is really 3/14. Alrighty, I think we are just about at time, if not a few minutes over. So I'm going to end the meeting here for today. You do have your first homework up in WebAssign. Please be working on that right away. Spend some time every day on the homework. That's the key to getting through this without ever feeling stressed out or overwhelmed. Next time, we're going to talk about inequalities. We're going to talk about interval notation. And then we will be done with the chapter 1 stuff and ready to start studying functions. So that's it. That's all I've got for you today. If you have any questions, you can come see me in office hours tomorrow from 1 to 2, or send me a Canvas message. Otherwise, I'll see you guys on Thursday. Oh, I do see there's something in chat here. Let me make sure this is okay first. Can 3/14 be simplified? No, because they don't have any common divisors. 3 is prime and 14 is 2 times 7, so there's nothing we can really do there. Alrighty, that's it then. I'm going to go ahead and end the meeting. Hope you guys have a good rest of your day. If you need to talk, send me a Canvas message or come by tomorrow's office hours. Take care.